So I'm Ilka Cassidy of Holzraum System and C2 Architecture and co-host of the Passive House Accelerator podcast. And I am very excited about today's presentation about Windows and window installation. So it's pretty cold here in Philadelphia right now. I think it feels like 15 degrees. And that's when you feel the weak spots in your house the most. So in my old 1870s house, it's definitely the windows, and actually mostly how the previous owner installed a few new windows about 20 years ago. So there's lots to learn for everyone, not just for passive houses. And with that, I'm handing it over to Shannon.
Thank you, Ilka. Welcome everyone to Construction Tech. We are going to be hanging out with Doug Pruess today, and he is going to share his expertise with us. I'm Shannon Pendleton from Sanderson Sustainable Design and Source 2050, and I lead passive house projects and consult in-house to help people get pricing, performance, and lead time in early design. So reach out to Ilka, reach out to myself, reach out to Kim. Let us know what you're working on. Let us know what kind of projects you have in the hopper and what kind of questions you're trying to answer, because we've got an entire network of professionals just eager to help you get there. So it's my pleasure today to welcome Doug Pruess, owner and product manager at Midwest Efficiency Supply. He's an AAMA Installation Masters Accredited Instructor, and he's based in Northern Illinois. And today he's going to share some valuable insights on airtightness and efficiency in window installation. But he's not just going to stick with one subject, because his experience covers a range of different project scopes. So everything from pre-con services and figuring out how to get involved with the team early so they can work with you to capture all the data you need. And then also how to do the training so that your whole team is ready to execute on the installs and the efficiencies that you're trying to meet. And then service and maintenance, and why some manufacturers, if you plan it right, will give you added incentives for doing things at a higher performing level. So Doug, thanks for joining us today. We're very excited to have you, and take it away. How's it going?
Pretty good. Thanks for having me. Yeah, it's just gonna be kind of relatively all over the place, just sharing photos from projects that we're doing, and then kind of talking through things that we've kind of seen before. So I mean, there's a service tech aspect where we'd love to get involved earlier, along with just kind of the design aspects and whatever. So basically kind of showing you from an in the field, because there's probably a lot of passive house consultants and architects, like that level of people here. And what I'm trying to show you is how to connect everybody together. So that's kind of just initially what we're going through today. And apologies if any of the presentation is a mess. It was we were kind of doing this last minute. So Doug Pruess, we kind of went through a bunch of the stuff. Passive house tradesperson. They're doing installation masters trainings. A lot of BPI certifications. I would say one of my early mentors was, say, Joe Konopacki, who kind of we took the high efficiency and testing route and kind of applied it more to Windows, and just kind of showing that more in the field. So essentially, when we're first starting on projects, we all see kind of these drawings, and the guys in the field see these kind of drawings also. And what we're trying to do is integrate things like your air barrier, your thermal barrier, and your water resistant barrier. So, and trying to stay ahead of these things. So a lot of times, let's say if I jump to a service, a lot of times in a service, we see a problem that was never seen, and you can go all the way back to the drawings where you can see that's where a hiccup happened. And this is just kind of one of those where kind of integrating the systems of people on the ground talking to people all the way to the top. So when problems do happen, we don't repeat them. Also kind of value engineering things of taking out certain products in openings and enlarging doors, or taking out. So can you see my mouse? I'm not sure what you guys can see.
Yes.
All right, cool. So like this kind of upside down triangle, like we had to start thinking about weight issues in this area and specify different thicknesses of glass. So that's kind of where we're there, and we kind of fix that by doing, say, structural moles. On this situation over here, where we actually took the hinge out of the mole area and flipped it over to this side so it's hanging off the side. Sometimes simple, sometimes just stuff that, I mean, you guys as architects, you got to know a little bit and be dangerous about everything. And so sometimes things can be overlooked and not thought about. So kind of run this stuff through, say, your window manufacturer, your installer, your contractor, of stuff they've seen in the field too. Just kind of another view of, different kind of window products, which I'm sure you guys have gone over before too. Let's see. Here we're actually in a training with some European manufacturers that they did in Wisconsin, and we're basically making from scratch pretty much, I mean, not verified, but passive house windows from scratch, and just doing it woodworking, and then just applying triple pane glass and things like that. This is a cool project for my buddy Andrew down in south of San Antonio, where we end up putting some triple pane windows in, and this is a weird situation. Oh, one project to another, I guess. Sorry. Like I said, presentation was slapped together, so apologies. So this one had LVL and structural beams, and we had to start considering the window install of how to integrate it. So I think I just popped that in there because of a cool photo. Here is, we're putting in a fiberglass door, and I don't know if you see up here how once it's put in, you kind of see the deflection on the head. So also you kind of see over time how the sill here is sloping down on the corners. So these are kind of things where you want to pay attention ahead of time during measure, and not just assume things are the correct sizing. Let's see here. Square, plumb, and level, and then also we're looking at what we can do for installation techniques. There's going to be strap install, there's going to be nail fin, there's different variations where you can use, let's say, angled pieces and move windows up and down, side to side. So this was a kind of a fun project we did with the Taylorville High School and Matt, where teaching the kids high efficiency installation techniques along with their pretty high efficiency building. If you guys ever run into these projects with these high school kids, it's just fun to be around and actually sitting and talking with them about like different types of jobs that are available, and just the interest that you get to see and seeing them hands first in these. So here Matt did a good job where they're actually sloping these sills. A lot of times the slope sill gets value engineered out. Also, I'm a big fan because it makes your life easier for wrapping the air barrier to the inside by saying wrapping this flashing all the way up and around the jambs and basically creating continuous. So that gives you an option of bringing that air barrier to the inside. So this is stuff that we can do on everyday buildings where just something as simple as an extra step can lead to a lot better of an installation and a lot better airtightness on our transitions, which we know can be a huge problem when we start depressurizing. Being service tech and working on other projects, we actually get to be involved in some really cool things. This is a project that is outside of Peoria. This is a National Guard base. There's not I can't show a ton of the photos, but these are the ones that we can. This is essentially where this building was monitored for over a year. And then what we did was we put in some high efficiency inserts to the inside because it was just cost prohibitive to basically take windows out of this large building and taking a building out of commission. So what's nice about inserts like this, so this is a fiberglass frame, and these are bulb seals, and what we're doing is we're just basically sending it into the opening, and it gets slid into these angle strips, which get embedded into the top of the sash. So once they are in, this essentially acts like a quad pane when we're talking with the people in these offices while they're working, and they're saying sometimes in the summer, these buildings, even with the AC going 24/7, the building gets up to about 87, 89 degrees. So nobody really even works in these areas. They go down in the basement. So now just a simple solution where you can actually pop into each one of these openings, these high efficiency storms, and you're getting almost, I wouldn't say quad pane performance, but you are definitely helping the envelope. I guess a blurry photo of a IR again, so apologies for some of this, but this just kind of shows on a cold day where you're actually getting a lot better performance, where you can actually see these fiberglass frames and slide in. These aren't necessarily for air infiltration. This is more for thermal and radiation. When you are designing in really big openings, doors, windows, things like that, I would kind of say keep in mind how you're going to get them there. We can make these cool openings on paper and they can be done, but something as simple as a service, this is in like an Indiana Dunes area, and where there's this pop and slide door where the glass blew. So it was a huge endeavor getting this panel up and over a garage. How to even get it there. We had to rig something up in a truck. So something to keep in mind. Not all products are going to have a failure, but there is a failure rate, which traditionally in the industry is about, I'd say 0.5% of glass packages for every manufacturer are going to be compromised at one point. So kind of keep that stuff in mind of serviceability. Certain different projects, something are simple, just walking through a multifamily, and product worked well, but we started going through, or the owner of the building started going through and started realizing that some of the windows, they just couldn't open. And so on a service call, bringing a crew out, walking through every single thing, we start noticing that every single shipping block was left into the openings. So essentially, it's communication. It's communication with installers, it's communication with the manufacturer even. Just a quick walkthrough of certain things where we can prevent a lot of services. So this building was well done. Just one simple thing can make things inoperable. Also pay attention to weird structures. I would never have said when we're installing windows that I need to know how to weld. Well, we had to weld this one because there was a structural piece in between where it had to be figured out, and basically talking with a structural engineer. This was kind of one of those situations that was, you kind of just make do with you have, and yeah, that was something we were just kind of thrown into and never expect to have a welder in there. Down in St. Louis is a really cool house. What I liked about this one was there's a lot of cool features. So let's just say this walkway right here. This was all quad pane glass. The reason I was there was because we had some quad pane glass that got broken in shipping, and I actually think there was a seal that was broken too. So this is just kind of eye candy, but also realize like there's a lot of heavy things, and we're actually, even in a design phase, there was conversations about some of this drywall coming down into this area, which would be blocking what's called a glazing bead, which allows us to reglaze the glass. So think about serviceability while you're designing. Doing air testing on projects. Speaking of Joe Konopacki right there. This is water tests and air tests. So this was just kind of initial smoke test that we're doing before the project got too far. Yeah. Real fast. All right. So the reason I'm showing you this photo is it's a cool design. It's a high efficiency multifamily. It's actually a passive house project, and this design makes a lot of sense, except for what we start noticing is you can start getting some water infiltration in this kind of design. This is where you're getting the window actually flush to the WRB, and there is no like overlapping tape or anything of the sort. Also, what we saw in this design was there was nothing spec'd in the RO, and there was a weep system here. So it was a value engineered, the value engineered out a slope sill, and then the whole rough opening didn't have anything inside. So essentially you're sealing the outside, you're sealing the inside. What that allowed was what I call a crosstalk across the whole project, where certain parts, so if there was a interior hole or something along those lines, it allowed just a direct path. So something as simple as filling that cavity with something, or preventing that crosstalk in a different way. Spray foam is fine around these areas. I look at it more as an insulator. I am not a fan of using spray foam as your air barrier, though. Just certain products during an initial install. Yeah. Here's a high efficiency cellular composite. There's a lot of different products out there. Let's see. Yep, I think this was another, yep, this is another weather shield one where you had to put into play just laying concrete up against the window. You always want to make sure you put some kind of buffer in there also, because they started having service issues because of expansion, contraction of concrete, things like that. All right, so this is a cool project. I don't know if you can see me, but that's the completion of it back here. It was in a few magazines. It was really cool, where just essentially a lot of glass. So when you're looking at projects, sometimes as simple as asking the question of, what different glass packages can I have to affect this certain building? And by that I mean is something as simple as like a room side low E made this project efficient enough, because there's so much glass, that they're able to downsize their HVAC. So I show this as, I like this project. I like the way it looked, how it was installed, but also the design can also meet thermal efficiency. And by just something as simple as, let's look at that different glass packages going from high efficiency to not. Yeah, so here we're just kind of measuring doors and windows. Sorry, a lot of these things are just kind of bumping through. You can see curved doors and sashes, things like that. Some of them are simple fix. A lot of times something like this that we see in the field, let's say a curved sash on, this is a sliding door panel. Kind of a funny story where we had one that was curved like a banana like this, and we ordered a new panel for the homeowner. And by the time it got there and we put in the new panel had the same deflection. So what we noticed was, in the meantime, between getting the new sash, getting the new panel, and closing and locking the old panel actually basically kind of married itself to the frame while we're waiting for it. So sometimes we just got to let products do their thing. We see this a lot with, say, weather stripping, where a door or a window is very hard to move, hard to operate. But that's just because a lot of the weather stripping, it just comes off of a roll in the factory. It's put in, and then by the time it works itself, it actually works the way it's supposed to. Here is something just kind of, I was actually walking from an Iowa Northwestern football game, and we're walking by a multifamily here, and I just noticed the design of this. So what I like to bring out is all of these units are blown. And so that means you're looking at, you went from maybe R2.5 to basically just somewhat of an air barrier. And it's all because of the design of putting an air conditioner right above, and it sits and vibrates on this glass the whole time. So that 0.5% of glass failure rate doesn't really apply here, because you're basically just, your AC is vibrating this glass to the point of failure. So different designs. I'm going to guess this is a retrofit kind of situation, but maybe not. So what do you see in this photo? What I see is doing a decent job. We're missing out on, there is some overlap on some of the flashing here. It's proper flashing technique. But if you can even just walk around and see something simple like, hey, look, this sticker right here. If you actually go zoom in and get close to it, what I noticed were the weeps are on the top. And so what happened here is these guys were moving quick enough in a multifamily, and they actually took a picture window and flipped it around. Sometimes stickers get moved. That's, that's fine. But this is going to be the first initial thing I'm looking at is, all right, I'm at least going to go give it a look. And luckily we did, because the weeps were on the top. This is a situation where water could have flowed into the top through the window system and started flooding out. So again, just something as simple as a sticker, or looking for a shipping block, talking with a manufacturer, just taking that quick time to make sure everything works properly. So there you go for kind of my quick rant. What I talk with a lot of installers, and a lot of times a lot of times they're just your framers. And I would say that's fine. That's great. No big deal. Maybe get the manufacturer involved before something's installed, because a lot of these guys are, looking to further their careers like everybody else. And they'll ask like, hey, what can you do to get more projects or do a better job? Or how do we do some of this kind of training and stuff that you guys are doing? And I'm starting to tell people, if you want to be treated, say, like a doctor or an architect, start acting like it. Why don't you just go get some trainings and start realizing that just pulling people off the streets to install windows, which are part of the interior, the exterior, the heating, the lighting, the cooling, it's almost a focal point, a piece of furniture in some rooms. And if you think about HVAC, you have to go to college for that. And this is something that you see windows get value engineered out of a project where a certain percentage of the house is glass. And if we spend all this time saying, hey, we're going to get these high efficiency, or we're going to get like a Wolf stove and all that kind of thing, which are great, just don't take that budget part out of your windows, because eventually it's going to catch up with you. So there you go. There's kind of just a quick rant of in the field, some service. I know we didn't go over a lot of like details, but what I see is details are, each project is pretty specific, and you can't really copy paste to every single project just because of obviously different points. So yeah, I think that's all we got for the quick ramble on a presentation.
So thanks for coming here today. If anyone has a window install question, feel free to pop it into the chat. You've got a lot of experience at your disposal here, and I know Doug would love to hear from you. We're going to throw a couple questions in the chat. The first one is from Scott Derber, but he doesn't have his microphone today, so I'm going to ask it for him. But before I do, Ilka, is there anything that you wanted to say real quickly about the presentation, or any comments you had?
Sure, and I have a lot of questions too, but we'll get to that later. I just wanted to say how important it is to actually see images, because it's so different looking at, or even as an architect developing these details, because you go, you look for example details and try and figure out what works for your project, but it's all theoretical, right? So I think what's really, really important is to actually go back and talk to the person who's going to install the windows, and hopefully has a lot of experience doing so, and getting some feedback in order to really, figure out your own detail in your drawing set. I think that's really important. Not only material selection, but also thinking about sequencing and how to set up these little pieces that go into that detail in the right way. So, but yeah, let's talk about that a little bit more later.
A lot of these guys in the field want to talk to you also. So that's kind of the thing that we don't think about, is if they're confused about something, a lot of times they don't know where to go. Something as simple as dropping off information on a project, where I've seen builders actually just, when the windows come in on a laminated piece of paper, or just even a piece of paper, it's just stuck with the windows of saying questions. There's QR codes on installation techniques. There's even the architect's phone number. And if somebody wants to call, or a lot of times a window manufacturer will have somebody. So as something as small as a single piece of paper that takes you 10 minutes can actually integrate a project and prevent issues down the line.
Awesome. Well, let's put a pin in it right there. And before we jump into questions, let's head over to Kim for sponsors.
Thank you so much. Thank you, Doug. Starting off with our founding sponsors, we want to thank 475 High Performance Building Supply, Ingley Architecture, Partel, Rockwell North America, and Zola Windows and Doors. Next up, moving on to our champion sponsors, we'd like to thank Bewiso, Cascadia Windows and Doors, European Architectural Supply, Facro, Intelligent Membranes, Icon Windows and Doors, and Source 2050. Next, on to our patron sponsors, we have Brennan Insulation and Airtightness, Bolzrom System, Innotech Windows and Doors, Lamelux, RDH Building Science, and Sanderson Design.
Without further ado, we will jump right into the questions. So the first one was from Scott Derber, and he wanted to know, Doug, he's doing a deep energy retrofit of a 1953 brick veneer home, and he's installing Colby and Colby's. I used those for like 10 years before I got Passive House certified. But he's using their new vacuum insulated glass unit, and he is concerned about the fact that there's no fin due to the brick veneer, and he wants to figure out the best way to install that. Now, I'm sure that this is it depends answer, right? It's probably
100%,
requires
yeah.
more time than a quick podcast or webinar answer. But any advice for Scott?
So complete system overview, quick answer. Yes, I would say like I can put, you can find me on LinkedIn, shoot me an email. I love figuring out crazy stuff like this. So I know I'm not going to answer this perfectly. I mean, vacuum insulated glass, that's fantastic. You know, we're initial phases of it, so I'm kind of at a wait and see on it. But to answer the question, windows without fin, I would basically say I've seen a lot of issues with brick veneer not addressing keeping water out of the RO. So I would say, you know how you're doing a standard AAMA install with a sill pan, that's something where I would actually integrate the sill pan all the way 360. And I don't see your system right now. I don't know what it is, so I don't know what I can or can't do. But I would definitely just make sure that you are panning the whole system and then using flashing tape, and then with a anchor bracket installation. A lot of times you're gonna spend the money on vacuum glass. Make sure you are centering that insulation into the center of the insulation of the building too, because I've actually seen projects where in a simulation, if you go too far out or you go too far in, it'll actually knock it out of a certification. So best practice is to integrate the center of your insulated glass into the center of the insulation of the building if it's structurally possible. And then
Good point.
and then
Perfect.
so yeah, you're gonna have anchor brackets to the inside. You're gonna be shimming those anchor brackets. And then you're going to a backer rod. There's probably a lot of cool tapes and stuff from 475 Supply or anywhere you can get it from. Just make sure you're doing things that are safe, vapor correct, and products that are meant to be on inside or outside. So super heavy, like overview. You're not going to figure it out from this, but feel free to email me. I'm always happy to have a quick conversation about stuff.
Perfect. Thanks, Doug. And I will say, I know Colby and Colby makes an extension jam, custom extension jams for brick molds. So ask your manufacturer what they suggest. And
So
how they
also
like
on that,
to
on
install.
extension jams from say like Colby and Colby, Weathershield, Marvin, things like that, if you're doing an anchor bracket installation, always ask for your jam extension to be shipped loose, because then you can actually screw through your brackets where they need to be, and then you can set your jam extension into that opening. So I've seen a lot of things where they have where they have anchor brackets that are off the jam extension, and everybody's like, well, where do you put these things? So also anchor brackets, don't be afraid to flip them around and install them from the outside. Just, you got to make sure you take care of water penetrations when you do that too.
Great answer. Thanks, Doug. Okay, you want to
Yeah, sure.
let us know
So
who's next?
yeah, so the next question is from John Snell. Are you still around?
I am. I wonder if I can ask a different question. I asked about the windsurts, but there's a more important question I had about the situation where you have exterior rigid foam our rigid insulation and frame strips and hardy board siding. And the windows are installed with the nail fin over the sheathing, and you've got hydrogap wrapping the sheathing and frame rough opening, and sausage, like intelligent membrane sausage, um, over the hydrogap to seal around the window frame. Could you talk about the need for and placement of metal flashing get between, well, where do you place that, and how do you get through this exterior 4 inches of rigid insulation and frame strips and hardy board? It's the windows, the nail fin of the windows up against the sheathing.
Right. So you're saying it's just kind of farther out in the building because of all the insulation. You also said something about metal pans. I'm not a monster fan of metal pans, just for the reason of is it just like a doctor, think about do no harm in your buildings. And a metal pan, if you have it go all the way from the outside all the way to the inside, this is a conduction point for really cold days. And
Yes.
it can actually be a point where you can get condensation on that pan. And that's at a perfect point where you're feeding water to wood, which is going to start creating health issues. So
And what do you do about flashing then? Do you use tape flashing or?
I love using a tape flash. There are a lot of advanced tapes out there now. There's even stuff that we think advanced, we think expensive. Not really. If you look for something like a PSA tape, pressure sensitive acrylic.
Yeah, like Hydro Flash?
No, I don't have a problem with that kind of stuff. I would actually have to look at that certain kind. I don't have a problem either with liquid applied. Just make sure you're applying it to the correct thickness. If you're going to use some kind of metal panning just because of aesthetics or because of design, then actually what you can do is separate the pan. So what you're going to do is you're going to put an outside part of the pan that drips down. You're going to put the upturned leg here. And then instead of making it just one full piece as a pan, you separate it and tape over the seam. So now you have a thermally broken pan that doesn't cost an arm and a leg. There are a lot of pan systems out there that can handle that too. As far as what you're talking about with like a lot of exterior installation and putting it on a nail fin, I think there's a term called ROESE. They're insulated rough openings, where you can actually you have to design it in because it makes the RO bigger. Where the issue is that you don't want to set a heavy triple pane window on extruded foam, no matter what PSI rating it is. You're going to want it on some kind of structure. So if you're not going to use that as a anchor bracket situation, which has its own, I wouldn't say problems, but things you have to overcome. I don't have a problem with your hydro flash, any of that kind of stuff, as long as you're sloping. Gravity's, let's hope, gravity's always going to be there. Use that to your advantage. So if you have a slope sill and you're addressing that, and then research things like insulated rough openings or structural ROESEs. They're becoming more and more common. They're essentially basically a big butt.
I agree with you about the weight problem being, if you have triple pane or quadruple pane windows, it's too heavy for these rough openings that are some kind of foam. Do you use wood when you've got a heavy window for getting between?
Yeah, definitely use that. I mean, it just think of it like you're designing your building of, if you're going to extend out, let's say using 2x6s or 2x8s, which is fine. Just think of, like we've all seen therm models. Think of it that way, where am I going to put insulation if I have actually have a point that is not going to be as insulated? So that means, can you insulate it on the inside and change those isotherms to be different? So I would look at it that way, where you don't have to put a whole 2x10. You might be able to just put, like, say, a 2x8, and then maybe insulate that little inside here, which actually insulate the whole situation. So hard to say and explain. A lot of the stuff is, I like to see a drawing and kind of go over it or see it in the field. But yeah, I mean, I like that you're thinking about everything that's involved there. And then also think about, are we over engineering this? I cut out a bunch of slides where we've actually had something where we worked with they weren't doing manufactured homes, but they were doing let's just kind of call it that. And they actually insulate it past a DOD rating. So that means it was 14-inch flashing, and all this stuff was there because it's trying to prevent, like, for a gas attack where it doesn't infiltrate into the building. So they went past DOD spec. That we don't need to over-engineer this stuff. I'm not saying you are. I'm just saying don't overthink it to the point of you're building a bomb shelter. A lot of times, $120 of flashing insulation is not better than a little bit of thought and a little bit of conversation for $30 or $40 of flashing insulation.
No, thank you.
That's great practical advice. Yeah. As one of my clients likes to say, this isn't a science project. We got to keep it affordable and we've got to hit the target. So our next question up is from El Caballero. It looks like you're still here. Would you like to unmute and ask your question?
Yeah, this is Lara. So I had a question on for retrofitting a house. Sometimes, with all windows that are outside of someone's budget, sometimes they want, to improve the sort of heat gain coefficient. And I wonder if there are specific films that can be applied to a single pane window, perhaps on the outside or the inside layer of the glass to improve that. And what would you recommend?
Yeah, I mean, there are situations where if you're talking just, I want to take care of solar heat gain, then I would say a film is perfect for that kind of situation where it is single pane. I would definitely be, I want to say leery, but that's not the right word. I would definitely pay attention if you're putting any kind of film on an insulated glass unit, 2 panes or 3 panes, aftermarket too, because a lot of times you're going to be voiding a warranty. And the reason that you're doing that, it's called the oven effect. If you put a storm door on a front door, there was a time when that storm door, if it caught sun, it would start melting components of the door. So they're actually venting some storms now and making other parts more resilient. I see that happen too when people put films or those like the ones where you're changing it to frosted. What you'll do is you're actually reflecting some of that glass,
Right.
heat in, and you're actually melting the spacer. So what you tried to accomplish, you actually just made it way worse by making it R1 now. So,
Yeah.
but single pane, I would, you say solar heat gain and single pane, and we're budgetary. I think you're barking up the right tree personally.
On the outside layer, you'll put it?
I would definitely, that one's going to be manufacturer specific, honestly. Like there's no like rule of thumb. If you have a manufacturer that says put on inside, inside to me makes more sense just because it's not going to get weathered. I mean, glasses, that glass has been there for who knows how long. It's probably going to stay there for who knows how long too.
Yeah.
So, restraints, and it's a fun puzzle game to figure out all this stuff. It's frustrating and satisfying at the same time.
Right. Thank you.
Thank you so much. So next up is Reed Rowland. Reed, are you still around?
I'm here.
Awesome.
I'm always here. In any event, you showed a slide where you were testing. Was it just air testing, or were you using a rainmaker for water intrusion?
So
And how often do you test when you install? Every time or every window?
no, if it's in the spec, it doesn't have to be every window. So you kind of have multiple questions there. I'll knock some of them out. So you're not testing every single window. A lot of times if you have a window that's being tested and that one passes, you can almost just test another window on the building that's like it, just to make sure that, hey, this awning over a picture window or something like this situation and this install works. One of the photos that I was showing you, we're actually using a duct blaster. We're actually fogging a window because we had some suspicions that there's going to be some air filtration issues, but we didn't want to bring out the full-time testers for that. So what we did was we fogged a window and basically just started walking around. And that's where one of those slides that I showed you, where we actually started seeing there was masonry clips on the inside, and then there was corrugated vents on the outside. That's where there was no insulation around the window. and it created crosstalk. So because there's so many interior penetrations that you have to rely on humans to seal, we started seeing things where the smoke popped through. So that was more investigative. There's really no spec for what we did on that one. But the other slide showed you a real test that actually had a spray rack on the outside that was being depressurized to match that. I think that was a CW50 window. So you can do whatever test you want, but it's not going to be necessarily certified. If we did that just to see where we're at and what we need to fix before we start bringing in testers, which aren't really cheap by no means.
All right,
Thanks, Reed. Thanks, Reed. Thanks, Doug. We had a last call for questions just a moment ago. So if you have one more burning question, throw it in there. And our next one up is from Lucas. Lucas, are you still with us?
Yep, I'm still here.
Hi, welcome.
Thanks. Yeah, so my question was, I've been kind of newer to the passive house scene, and I've been hearing a lot about wanting to center the installation, essentially center your window in the envelope itself so that all the installation is in line. And I was just wondering what the purpose of that is. I have some kind of thoughts about what it might be, but I wanted to hear from the experts.
Gotcha. So the experts on this question are going to be more your verifiers, the people actually doing those isotherm models, things like that. So what I'm doing is I'm regurgitating to you what they told me, and what they've shown me is that when you're taking two sections of insulation and pulling them apart from each other, you're creating a direct point of energy transfer. So essentially, when you combine the insulation of the window vertically with the installation of the wall, I've seen where you see those isotherms not get so crazy. They start calming down. And that's just something that was shown to me from like I did a training from EMU at one time. So that was something that was shown to me. So ever since then, I've been essentially trying my best to put them in line. And I've seen projects that fail because but didn't pass initially because the window was not designed into the right place. So
Perfect. Doug, I just threw a link in the chat to an image, and
Perfect.
actually that one's from JLC Online, and this one's from 475. It shows the window in different placements in the walls using thermal modeling. And there's a couple things at play, right? The window is part of your continuous insulation. So one of the 5 passive house principles is continuous insulation. So you want them to be in line or touching. And the more they touch, the less the isotherms, those colored lines, have to wiggle to travel that continuous path through your building. And not only does that complete your insulation, but it reduces condensation risk and comfort risk. So you don't want condensation because of health concerns for the air and also durability concerns for the install. And you don't want comfort risk because you're buying these really expensive windows in great part to be comfortable. So there's lots of reasons, but those are the primary ones that I share with my clients. Ilka, I'm sure you've got thoughts on this one too.
Yeah, I mean, I totally agree with what you just kind of explained, that you have to be within a certain range, but it's not absolutely clear cut either, because if you do energy modeling, if you use like a WUFI or a PHPP, you can kind of show basically where the window is located within your envelope. And the more you push it out, the more gains you actually have, right? And the more you push it in, the less amount of solar gains you have. So there's a little bit of a game that you can play there as well, depending on what fits best for your project, what you kind of need to meet at that moment, but also what the design is. I mean, sometimes you really want to have that deep sill and push the window out as far as you can, or the other way around. So I guess it's just that it's not one way that solves all if you're within a certain reason there. So, but we have another question from Alex. Alex, would you like to ask your question?
Hello, everyone. Thanks, Doug, for the presentation. Towards the beginning of the presentation, we saw some images of a multi-family project, and then there was a picture showing the window screen kind of hung in from the outside and clipped into the window, kind of squeezing the gasket a bit. I've seen that on several projects. In your experience, does that interfere with the performance, or is that so minimal that it doesn't actually affect the performance of the window?
Gotcha. So I don't have the tilt and turn with me. So a lot of these windows, actually a majority of the windows, let's say outside of your major manufacturers, what I mean by that, like North American, like what we're used to, they're multi-gasketed. And the gasket that you saw, that is not a primary gasket. The primary is in the center. So there's 3 gaskets. So we can adjust air infiltration on an internal gasket. The main gasket is just there. And then that outside gasket, it's meant to basically push water off the window system. But if it gets into the window system, there's an internal loop that gets it out. So what we noticed is Americans love screens. Makes sense, I get it. But European windows aren't designed to have them the way we expect it. So it's essentially putting a square, like a round peg in a square hole. So clips like that actually, I see, make sure that we have screens at work that fit into the openings. They used to just have like little plugs that were plugged into the side. But what you'll see over time is sometimes those plugs will break off. So that metal system that clips to the inside, those windows get tested sometimes with screens in them too, and are just fine. So that was the long part of it. The short part of it is multi-gasketed.
Thanks. Yep, that makes sense.
Yep.
Do we have time for one more question, or do we have to wrap it up here? Kim?
And do one more.
Okay, let's do one more. I think next up would be Carl Eklund.
Carl, you're muted if you can hear us.
Okay, can you hear me now?
Yeah,
Yes.
welcome.
Okay, so I'm building a house by myself, and I'm a civil engineer, but with this problem with the windows, I'm putting the windows double pane or triple pane on the in center line of the 2x6. Okay, and I'm going to use fast flash, Prosoco's fast flash on the inside there around, but should I actually be taping the outside circumference or perimeter of the window also?
Okay, so you're talking about difference with seeing like a passive barrier or a passive barrier system and a surface barrier system. So what you're doing, because you're using clips and you're putting it into the middle of the wall,
Right.
we're going to treat that more as a surface barrier. So what you're going to do is square plumb level always. You're going to use fast flash. You're going to have to either kerf your 2x6 sills to give yourself that drainage slope.
Right.
To answer the question about, I'm fine with a fast flash. That's great. Maybe 360 the window on that, or the RO. And then as far as tape, you're going to have to go to, you're going to have to use an externally rated tape. And then on the inside, we're going to find, like, there's many different flashing tapes from many different manufacturers. There's a couple sponsors here on this program where you can go there and just make sure that when you're buying that tape, it is for what you're using it for. Don't use an internal tape, exterior, that kind of stuff.
Yep.
Also, things like on the exterior, you can be using, let's say, bent metal flashing and rely on a really high quality tape, or I'm sorry, really high quality sealant. We didn't talk about this much either, but you guys that are here in the very end and gals, make sure you're specifying sealants that are past, say, performance grade 50. And there's a lot of bad sealants out there too, but there's a lot of good sealants too. So, and then in the internal, you can use spray foam, you can put in whatever loose insulation, but just keep in mind that you need to have an air barrier now. So a lot of times just a backer rod and then sealing that to your RO, that's going to create your air barrier. So now you have a weather resistant barrier, water resistant, you have thermal barrier, and you have an air barrier. Just keep them separate or just think about them separately and
Right.
don't put them all into one.
Great, thanks.
Yep.
So I think we've actually reached the end of today's construction tech. Thank you, Doug, so much for sharing all your knowledge and wisdom, and thanks for everyone for asking great questions. And yeah, make sure you check out all the other resources on the Passive House Accelerator website. Thank you so much.
And if we didn't answer any questions that you have, my email, you can get it on my LinkedIn that was shared, and I'm more than happy to have conversations outside of this. Appreciate it. Thank you all for having me.